This is a demonstration of the UniMocXButton control in a PowerPoint presentation. As you can see, we have here a UniMox control, a UniMox chart, the UniMocXButton, a UniMox gauge, and a label for the gauge. So we have a patient that is normal, no particular difficulties. If we click the button, we've made the patient very ill. Cardiac index is going to be down below 2.0. And so this is essentially the use of these buttons. If we go to the next page of our PowerPoint presentation, we can see additional uses of the button controls. What we've done is we've made an LVAD control right here box, and so we can implant a Thoratec HeartMate 2 device simulated in this patient, and it initially starts off at 8,000 RPM, and you note that the cardiac index is now rising to above 2, and so we're going to want to increase our RPM of the HeartMate 2 device until we get a cardiac index of say 2.5. So that's what these buttons do: increase and decrease the speed. And so let's go up, say, 9,000 RPM and see how we're doing at that point. And you can see we're at about 2.3 for cardiac index. Let's increase it to 9,500. 2.5. So that's essentially what we're looking for. Probably 10,000 RPM is going to be our target setting for this patient. Okay, so let's go in and see how all that is done. So we'll stop our slideshow presentation. So this initial button here, which makes the patient sick or well, as the case may be, it's set up with a button type, and it's a circle. If you remember, on the buttons on the VAD control, we have a left and a right button to show up and down increase and decrease of the RPM. We could easily have made it up and down buttons also, but that's essentially the shape of the button. We have the network parameter here, making sure that we control the proper UniMox control. We can change the colors, on and off colors of the button as we see fit. And then there's this little checkbox here for fire on activate. We'll go into that a little bit later. So what happens is when you click on the button, it will, if it is currently on, it will turn off. If it's off, it'll turn on. If there are no off commands, then the button is considered a momentary button, and it will only fire the on commands when you click on it, and it will never stay the on color. It will only be on while you're clicking. Okay, so what we've done here is we've programmed this button to set user data buffer 0 to 1, and the reason we do that is so that the button will know whether or not it should be on or off. If the user data position is 1, essentially what a button does, it continually checks the simulator to find out if the first item in the command list is activated or not activated. Now there are some activations that won't report back as being activated or not activated. Usually those have to do with increments. So to make sure the button turns on and off, turns green or red as we require, we go ahead and use the user data so that it will report when the button asks the simulator, it will report the proper values so that it knows how to turn on and off. And to make sure that we know the condition of the patient, initial condition, we go ahead and reset the patient back to 0. Back to its default condition. When we do that, we reset all the user data values back to 0. So we need to set the user data back to 1 again. So the first one of these user data commands is just simply so that the button knows what it's looking for to know whether it's turned on or off. Then we go ahead and turn off all those user data, we zero all the user data. Now we reset it, and so this is so that the simulator will actually return the proper value so that the button will know it's on. And we go ahead and we have different reference volumes, etc. that we set to make the simulator behave as if we have an ill patient, and those you can see in the UMExplorer demonstration video. Okay, now the off button, when the button's on and we click it again, it will turn off, and all we've done there is we've reset the patient back to its defaults, and we've set the body surface area to 1.75. Now the reason we're setting the body surface area to 1.75 is so we'll get the cardiac index that we're looking for. So when we initially start up this thing, we also want to make sure the cardiac index gives us the value we're looking for. So we've also programmed the initial condition of the UniMox control itself to provide a body surface area of 1.75. Okay, so for the LVAD control, similar situation, we've essentially programmed this button here to implant a spin VAD, and the off command is to explant the spin VAD. Spin VAD and a continuous VAD are synonymous. Note that we're not using the user data areas for these things because the simulator will properly respond with the value whether or not these particular devices have been implanted. And we're still using a circle as our button type. To decrease the VAD RPM, we have this button which is set up as a left pointing arrow, and the on command is to increase the revolutions per minute by a -250. So we're incrementing by -250. Now again, because of the fact that we don't have any commands in the off command list, that means that the button will behave such that when you click on it, it will turn green momentarily, and it will send this command to the simulator. But it won't stay green. So that's the purpose of not having any commands in the off command area, is that it will just give you a momentary button color change. We have similar commands in the right pointing button. Notice we have a right pointing button. On commands we're increasing by 250 RPM, not minus 250 RPM, and we still have no off commands. So that is the setup of those buttons. So we'll go ahead and go back to our presentation, start it up again. Remind you of what this is doing. We've had the initial condition of our UniMox control so that it has a body surface area 1.75, and that provides us with the proper cardiac index that we're looking for. And if we click on this button, it will send the set of commands to this simulator so that it will make the patient ill, provide low cardiac output, and also low cardiac index. So then when we switch to the next slide, it goes to our LVAD control slide. We're still in the same situation we were when we left the first slide, and we still have a very low cardiac index. When we click on the center button on the LVAD control, we turn on our LVAD, and it's at 8,000 RPM, and we can increase or decrease that RPM value by clicking on those buttons. Now, one of the nice things would be to make it so that when we switch to the slide, that it would automatically turn on our LVAD. So let's show you how to do that. We go back to our design mode, go to the on button for our LVAD control properties. That's when we're going to go ahead and use this fire on activate. What the fire on activate means is as soon as we go to that slide and that slide becomes active, this UniMocXButton also becomes active. And what we're telling it to do is as soon as it goes active to go ahead and go to the on state, send the on commands to the UniMox control and go into its on state. So let's go ahead and replay our slideshow. And so we have a patient that is doing fine. Patient gets very ill. Cardiac index drops precipitously. And when we switch to the next slide, you see that we automatically turn on our LVAD when we go to the slide, so we don't have to do that when we're in front of our audience. It would automatically have done that. And then we can demonstrate what happens if you turn off the LVAD by just clicking on the LVAD control button. So that's how you use a UniMocXButton in a Microsoft PowerPoint presentation.